This is a continuation of solving equations with logs on them. This is what we've already solved equations when we have logs on one side of the equation. And I wanted to show you what it looks like if you have logs on both sides of your equation. These are both log base 10. I'm going to make sure they have the same base. I'm going to show out this step, but you don't really have to. This would be 10 to the log. I can raise both sides 10 to the power. And when I do that, the logs go away, and I just get a squared equals negative 2a plus 3. I want to point out that really what I was doing was I was saying, oh, these are the same base, so I can ignore them. I'm not really dividing by logs. I'm really raising it 10 to the power, but they're the same base, so I get to ignore them. And at this point, I have a quadratic, so I'm going to do that quadratic, and I have a squared plus 2a minus 3 equals 0. If I factor that quadratic, I get a plus 3 times a minus 1 equals 0, because 3 times negative 1 multiplies to make negative 3 and adds to make positive 2. So I have two possibilities. I have a equals negative 3 or a equals 1. My next step is to make sure that both of those possibilities actually make sense. If a is equal to negative 3, I have log of negative 3 squared, which would be log of 9. And then I have, on the other side of the equation, I have log of negative 2 times negative 3 plus 3, which is log of positive 6 plus 3 would be 9. This is okay because I'm doing logs of positive numbers. I'm totally fine with that. I just have to remember that for logs, what's inside the log has to be greater than 0. I'm also going to check a equals 1. When I do that, I get log of 1 squared, which would be log of 1. And then I'm going to plug 1 in on the other side of the equation. I have log of negative 2 times 1 plus 3. That's also okay because it turns out to be log of 1. This works out because those logs are legitimate. I'm allowed to do log of a positive 1. If I had gotten log of a negative number, then that solution would be extraneous. All right. You can also have multiple logs in your problem. If you have multiple logs, you're going to use log properties to simplify them into a single log. So here I have natural log minus natural log. That's the same thing as natural log of negative 5x minus 5 divided by 9, writing it as a single log. My next step is to get rid of that natural log, so I'm going to raise both sides e to the. And here the e to the cancels out, so I have negative 5x minus 5 divided by 9 equals e to the 4th. I'm going to multiply by e to the 4th. By 9. 9 e to the 4th is a very large number. I'm going to add 5. And I'm going to divide by negative 5. If I do my check for extraneous solutions with that, I'm going to put a very large negative, multiply it by negative 5. I'm going to get natural log of a positive number. I can actually check to make sure my solution is correct. If I do that check, I'm doing natural log of negative 5 times 9 e to the 4th plus 5 over negative 5 minus 5. These negative 5s, and I'm doing subtract natural log of 9, these negative 5s cancel, so I have natural log of 9 e to the 4th plus 5 minus 5. And so I have natural log of 9e to the 4th minus natural log of 9. I bring the 4 down in front, or I can split this up as a sum. So I could say this would be natural log of 9 plus 4 natural log of e minus natural log of 9. Natural log of e is 1. So this would be natural log of 9 minus natural log of 9 would be 0. So I get 4, which totally checks out. All right. If you still need to look at this work, please pause now, because I'm going to delete my work so that I can have enough room for the second problem on this page. Maybe you can already figure out where you're going to go with that second problem. Right? I have division, so, well, I have subtraction, so I'm going to turn that into log base 9 of x over x plus 4. Since I have logs on both sides of my equation, I can raise both sides 9 to the power, so these logs can go away. I'm going to multiply both sides by x plus 4. And I'll distribute the 7. I'll subtract x and subtract 28. So I have 6x over here and negative 28 on this side. So x is going to be negative 28 over 6. This is a problem. I can't have x being negative 28 over 6, because then I'm going to be taking the natural log of a negative number, which is not allowed. That's outside of the domain of log, so of any log. So this is the only answer, and it's extraneous. So this problem has no solutions. All right. So now you should be good at solving equations that have logs in them. Thank you so much. Bye.